Friends, as you might already know, as a member of the EAGE AI committee, we contribute to a monthly newsletter that includes online courses, open source code, research papers, open datasets, and anything else related to AI/ML in geospace. The newsletter is designed to help geoscientists navigate an environment flooded by the information abundance. You can read the newsletter on the EAGE's website and LinkedIn, or you can watch a video version of the newsletter on this channel. Today I'm covering the second newsletter for the February 2022. Okay, let's start with the content. The first part is about online educational materials. Google Machine Learning Crash Course is a quality content for 15 hours. A sequence of modules featuring video lectures, real-world case studies, and hands-on practical experience are included in this course. It walks the listener through the entire process, from identifying a problem to predicting models using TensorFlow APIs. If you have little or no ML background, or only have a surface level awareness of this subject, then this course is right for you. The course is designed with a practical approach in mind and is taught by Google researchers in a structured manner. When sections are completed in order, the flow of the content makes it easier to understand them. Starting with loss and gradient descent, work your way through the entire process of building classification models and deep neural networks. It's worth noting that playground exercises are excellent, assisting with visualization and comprehension of the ML concepts. Then of course this AI/ML channel. I probably was not clear from the beginning what this channel was about. Probably. I didn't know it myself. I want to make this point clear. This educational conversational channel will feature curated reviews of recent AI/ML publications, AI interviews, fundamental AI/ML concept explanation, and the latest news about AI-related conferences and gatherings. Information regarding machine learning development in oil and gas is dispersed throughout numerous publications, blog posts, and snippets of information here and there. It is good to have everything in one channel. I also make an additional effort to create materials that are easy to understand and free of complex mathematical calculations, as much as I can. And the next one is deep learning tutorials for seismic interpretation using Python. Check out Theo Arona's GitHub repository if you want to get started with deep learning for seismic interpretation. It includes 9 tutorials on using deep learning for salt detection, fault delineation, and horizon tracking. Many datasets and tutorials are available online to help you to get started with machine learning and deep learning, but almost all of them are tied to some distant field hands-on examples like classifying handwritten digits. It would be better for geoscientists to learn and to apply their knowledge to relevant problems within the geoscience domain. By the way, if you know any useful resources for geoscientists, then reach out to me in the comment section. All recommendations will be considered for future newsletters. And the next one is the dataset. The Groningen gas field. Utrecht University released a dataset of the onshore Groningen gas field with faulting and a massive salt body. The dataset contains reservoir model, seismic interpretation, well information, and many more data. Be mind that the part of the data comes as Petrel project. We usually don't have enough labeled data to experiment with and design better practical solutions. This dataset is unique because it includes interpretation, which is a very rare occurrence. And the last one is the paper, Deep Convolutional Neural Networks for Automatic Fault Recognition from 3D Seismic Datasets. UN and colleagues publish interesting research that challenges the concept that fault detection is a segmentation problem in deep learning. They compare holistic edge detection and richer convolutional feature to the current state-of-the-art segmentation architectures. Along with the architecture comparison, the authors offer some insights into which augmentation, patch reconstruction, and annotation steps are most effective. It introduces a new way of thinking about fault delineation in deep learning as an edge detection problem. It includes GitHub code as well as the label dataset on Google Drive. Consider checking out our previous newsletter, where you might find something interesting or useful there. Thanks for watching and see you at the next one.